Hi students, welcome in today's lecture. So today's topic is capillary action and height of fluid in the capillary tube. Uh, I have also posted the other lectures videos, so you can watch on my channels if you want to watch any other video. And in today's lecture, we'll discuss this derivation of the height of the capillary. And there are two methods of the derivation. One is the pressure method, another one is the force method. So both of the methods we'll discuss, and then in this we'll do the exact calculation, and then later on we'll find out a formula that we can apply in any of the question. Alright, so here I have taken a tube, and in that tube, when we put this glass tube in the water, then the water will rise a bit height compared to the nearby fluid. So if I take nearby fluid is in this container is somewhere here, so in this tube it is going to rise. This tube is having a very small radius, then we can easily see this effect. So this phenomena of rising the liquid level in a any container because of the tube, a very small tube, that is called as capillary action. Right, now what are the practical application of the capillary action? Like, let us suppose if we take plants. So the plants are taking out the minerals, they are taking out the water, everything from the ground. So they don't have any hands. So how they take out is with the help of the capillary action, where the fluid will rise, and then that is going to come up with the help of this capillary action. So the region behind this is basically, as we know, there are the cohesive and the adhesive forces. So adhesive forces between the surface of the glass tube and the liquid are going to attract in the upward direction. So because of that, it is going to rise. Okay, so we have understood the region and we know the practical application. So likewise, there are many applications, like even when we use the pen. So pen is going to, the liquid in the any ball pen or any kind of pen is, or the ink is going to come out because with the help of the capillary action. Likewise, there are many other examples, like when we dip any cloth in the water, half of this cloth in the water, so then the other part is also going to get wet because of the liquid rising in that. Okay, so all those things are happening because of the capillary action. So here I have taken a fluid that has a density rho, and the radius of the capillary tube is r, and the radius of the surface, if you look here, this is a surface, upper surface. Let me just, okay, if I put this here, this is the surface. This surface is also having some radius of curvature, and the radius of curvature of this surface is small r. Height rising is h, that we need to finally come to this expression of h. And the angle of contact is theta, rho is the density, and the surface tension coefficient, let us take it as T. T is the coefficient of surface tension. Okay, so let us go. First method is pressure method. Okay, so with the help of the pressure method, we are going to calculate this. So in the pressure method, I will take 3 points. This is point 1, point 2, and the point 3. Point 3 is right below the surface. Okay, so tell me, what is the pressure at the point 1? Think of it. What is that? It is atmospheric pressure. Okay, what is the pressure just above this? Let us take one more point. So I have point 1, 2, 3 and 4. Alright, so if I ask you what is the pressure at the point 1, you will say atmospheric pressure. That is also equal to the pressure at the point 4, which is P naught. Alright, now what is the pressure at the point 3? pressure at the point 3 we are going to calculate with the help of the excess pressure concept. Now this point 3 is in the convex side of this surface, so it will have lesser pressure compared to this point 4, and it will reduce by a amount of 2t by r, because this is a, and below we have a kind of liquid drop. So P3 will be equals to P4 minus 2t divided by r, where r will be the radius of curvature of the surface. R will not be the radius of the capillary tube. Okay. All right. Now tell me, what will be pressure at the point 2? Think about it. What is the pressure at the point 2? Will it be pressure at the point 3 plus rho gh, isn't it? Which is pressure at the point 4, pressure at the point 3 is pressure at the point 4 minus 2t divided by r, and plus we are going to add the rho gh term in that. Okay, then we have pressure at the point 4 is P naught. All right, so pressure at the 2 is P naught minus 2t divided by r plus rho gh. All right, now you tell me, is it a static fluid? Yeah. So then pressure at the same height, will it be equal? Yes, of course. So can I say that the pressure at the point 1 and the 2 is equal? So I can say that the pressure at point 1 is equal to pressure at point 2, which is equal to P naught, and that is why P naught is going to be equal to this term, P naught minus 2t by r plus rho gh is equal to 0. Okay, so P naught is cancelled out. So then you can say that the rho gh is going to be equal to 2t divided by r. So then the h value is going to be 2t by rho g. Okay, 2t divided by rho g r. This is the h value, capillary height rise. We have done the calculation. Okay, we have reached, but because sometimes the radius of curvature of the surface will not be known, but the capillary radius will be known. So let us find out what is the value of this radius small r in the terms of capital R. We have also been given that the angle of contact is theta. So if I just this part, if I redraw here, so then it is going to look like this. We have this surface like this. Okay, this is the perpendicular surface. The angle between them is theta. Okay, and what do we have right now is like this. This is capital R and this is small r. Okay, so this angle is theta. Then look, this angle, if this angle is theta, so then this angle also becomes 90 minus theta. This angle becomes 90 minus theta, so this angle becomes theta, right? So what is the relation between capital R and small r? Can I say that the capital R cos theta is equal to small r? All right, so small r value becomes capital R divided by cos theta. So if I substitute this value right here, then I'm going to get that the h is 2t divided by rho g capital R divided by cos theta. Cos theta will go in the numerator. So this is the capillary rise height formula. H is equal to 2t cos theta divided by rho g r. All right, so this is the height. We have done the calculation with the help of the pressure method. The other method is the force method. With the help of the force analysis, we can do the calculation. Okay, so let us look what is the force analysis. Look, if we take the liquid which is there in the capillary tube, it is first of all forming a small minuscule here, and then it is like this. Okay, what is the pressure here? It is P naught, and pressure here is also P naught. So pressure is not going to apply any net force on this part of the fluid which is there in this. So what all other forces will be there? There will be some gravitational force, then there will be some tension force, surface tension force. So let us look what is the gravitational force. It will act in the downward direction. Okay, and the gravitational force becomes mg. So just I need to find out the m can be written down as rho multiplied by volume multiplied by g. Okay, and the other force is the surface tension force. Surface tension force is acting like this. Surface tension T is acting like this. It is also making, if I just draw it nicely, so something like this, this angle is theta here. So because of that, the T tension is acting like this, T tension is acting like this. So there is T cos theta in the upward direction. So because of that, the total surface tension force becomes T multiplied by 2 pi r multiplied by cos theta in the upward direction. Okay, so now to equate these forces, there is no other force, I just need the volume. Alright, now I am taking this height as the h, this height is h. So this height is h, so then I can say total volume is basically volume of this part of the cylinder, which is pi r square h, plus volume of this part of the fluid, which is volume of this part of the cylinder minus volume of this sphere, which we can approximately consider it as the hemisphere. So that is pi r square r minus 2 by 3 pi r cube. Okay, so basically it is pi r square. If I take out common h, and this side will have the r by 3 common. Okay, so this is the value. Now we can equate both of the forces. So the gravitational force becomes equals to surface tension force. So surface tension force is equal to the gravitational force mg. So surface tension force is T times of 2 pi r times of cos theta is equal to mg. M is rho and v is pi r square h plus r by 3 multiplied by g. Okay, so pi r square is cancelled out. Okay, so we get here that this value is 2t cos theta divided by rho g r is h plus r by 3. So h value is 2t cos theta divided by rho g r minus r by 3. Okay, so this is the height rise we are getting mathematically. So in this there is one more term, minus r by 3, right? This minus r by 3 is a kind of correction we need to do for the liquid which is not there in this minuscule small part, right? Otherwise, approximately we can just say that the height rise becomes h equals to 2t cos theta divided by rho g r. All right. So look, this is a formula that you can repeatedly just repeat it, like you can just say h equals to 2t cos theta divided by rho g r. So then if you repeat 2-3 times, then you will be able to memorize. Okay, so that is nice method to memorize. And then In the next video I'm going to post a question on this. I hope you must have understood how do we calculate capillary height rise. See, this formula you can memorize, that is best. If for the JEE Mains, JEE Advanced even, you can memorize, because there is no need to reinvent the wheel. When you know that this is how the derivation is there, you are not going to do the derivation in the JEE Mains or any of the competitive exam, right? So best is you know the thing, you understand the concept and memorize this. That is going to help you a lot in the exam. All right, so that is all for the today. Hope you liked this video, and you can also watch the other videos available on the channel. You can share with your friends. Okay, thank you.